Okay, so this is week 3, day 1. List the factors of 20 and 35. Circle all the even factors. The factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 35 are 1, 5, 7, and 35. It also says to circle all of the even factors. 20 is the only number that has even factors between 20 and 35. A number is even if it is divisible by 2 or ends in 0. So for example, a number that ends in 2, 4, 6, 8, or 0 would be an even number. Okay. Number 2, compare 3/8 and 3/6 by drawing models to prove it. So here you can see that I have drawn a model, and I labeled this model 3/6 because I have 3 of 6 pieces. And I drew another model with 8 pieces, and this one is 3 of 8 pieces. So 3/8 is less than 3/6, as we can see. Okay, number 3 says, this week the second grade collected 3 times fewer pennies than 5th grade. If second grade collected 1,845 pennies, how many pennies did the 5th grade collect? So that means that 5th grade's pennies are 3 times more if second grade collected 3 times fewer. So they already gave us what second grade collected, which is 1,845. So that is 3 times fewer, which means I need to find for 5th grade, so I'm going to make it 3 times more. So I multiplied 5 times 3 is 15, carry 1. 3 times 4 is 12, plus 1 more is 13, carry another 1. 3 times 8 is 24, plus 1 more is 25, and then 3 times 1 is 3, plus 2 makes 5. So 5,535 pennies in 5th grade. Complete the table. So if I have 16 ounces here equals 1 pound, and that's just something we remember from 4th grade. So if I have 7 pounds, what do I have to do to figure out the ounces? I have to multiply to get my ounces. If I have 8 ounces, I have to divide 8 to get a half. Because if I'm thinking, I know that we haven't talked about dividing with fractions or dividing numbers into a bigger number, but we can think about that. What would half of a pound be? Half a pound would be 8 ounces, because 16 divided by 2 would be 8. Okay, so here I'm given 5 pounds, so what do I do again? I multiply 5 times 16, and that gave me 80. As you can see, I did all of my scratch work here, and I should see your scratch work on your papers as well. Okay, week 3, day 2. It says, using mental math, which is the best estimated product? Again, I have an estimated product. I'm multiplying with the product. I'm estimating, which means I'm finding compatible numbers. So I looked at 417 and 27. 417, my closest compatible number would be 400. This is not close to 500, it's closer to 400. 27, is it closer to 20 or closer to 30? It's definitely closer to 30. So I look at my first 2 numbers, which are 4 times 3, and that would be 12. And between these numbers, I have 3 place values that I have to account for. So that would be 1, 2, 3, which would give me 1, 2, 3 zeros there. So I showed the work here. That would be 3 zeros, or 3 places. 3 times 4 is 12. So the mental math gives me about 12,000 as an estimate. Okay, number 2 says, use the standard algorithm to find the product of 417 times 27. So that's what I did. That gave me a partial product of 2,919, a partial product of 8,340, and then I added. Now it says, what strategy or model could you use to verify or check your work? So you could use partial quotient. You could use, I shouldn't say partial quotient. It's partial product. Partial product. You could use magic boxes or windows, what some people say. You could also do lattice. So I did one, and I did lattice, and I did a check with lattice, okay? And so there is my number. For number 2, which I got 11,259, I got the exact same thing when I used lattice. Okay, use this number to answer the question. So I had 3,333 and 33 hundredths. How many times greater is the 3 in the thousands place than the 3 in the hundreds place? So first I have to find the 3 in the thousands place. There's the 3 in the thousands place, and there's the 3 in the hundreds place. So what could I multiply 300 by to get 3,000? It would be 10, because it's 10 times greater. How many times less is the 3 in the hundredths place than the 3 in the ones place? Well, here's the 3 in the hundredths place, and here's the 3 in the wholes place, or the ones place, or units place. So that's several different words I could call it. I could call it units place, I could call it whole, or ones. Okay, in 5th grade we usually use the word unit, so I hope you get used to seeing that word units place. Okay, so I'm looking at this, and what would I have to divide by to get, if I'm in the hundredths place, what would I have to divide by to get this number? Or what would I have to multiply this by to get that number? And it would be 100 times less. Okay? All right. 10 times less would bring me to the tenths place, and then another 10 times less would bring me to the hundredths place. We have not talked about this skill, so I'm hoping that some of you are able to pick up on what's happening with place value as I'm explaining this problem. Okay, label the following number line using these numbers. So we were given 2/5, 0, 1/5, 4/5, 3/5, and 1. As always, we eye our number line and decide as best as we can how evenly we can divide this up. I have a 5 as a denominator, so I know that this line is going to be broken up into fifths. This automatically is 0. This is 1. Okay, so I'll make sure I draw my lines there. There's 1. If this is 0 and this is 1, and I have to divide evenly into 5 sections of 5, then I'm going to have 4 lines but 5 sections. Okay, so this 0 is 0/5. This would be 1/5, 2/5, 3/5, 4/5, and then this would also be 5/5. Even though 5/5 is not here, I'm still going to write it. And even though 0/5 is not there of those numbers, I'm still going to write it as well, because I know that 0 is equal to 0/5, and I know that 1 in this case is equal to 5/5. So use the symbols to compare the fractions. 1 is greater than 3/5, 0 is less than 4/5, and 5/5 is equal to 1 whole. Okay, so looking at day 3, week 3, day 3, it says to use 2 strategies to find the quotient. So in this case, I used area model. I thought about what I knew about 4 already when I had this number 296. And if I cover up one of those numbers, I see the number 29. Well, what times 4 gets me close to 29? It would be 7. 7 gets me close to 29. It gets me 28. But I don't want 29. I need a hundredth number. So then I'm going to add a 0 here, or add a place value here by putting that 0 behind the 7. Now I'm working with 280, because 4 times 70 would give me 280. So my first big chunk that I'm taking out of 296 is 280, and multiplying 4 times 70 got me there. Okay, so now I take my 280 and I subtract it from 296, and that gave me 16. Well, right away I know that 4 times 4 is 16, so I just went on and put that whole chunk of 16 there, and I put my 4 here, because 4 times 4 equals 16. So am I done yet? Kind of. I still have to add my partial quotient, so 70 plus 4 equals 74. Okay, next method I used was partial quotient. And so the first thing I do, just like I did over here, is I look at these first 2 numbers, and that's 29. Again, 7 times 4 gives me 28, but I need that extra place value since this is a 3-digit number, so I'm going to make this number 70, and 4 times 70 is 280. So I subtract here, and that gives me 16. So again, 4 times 4 is 16, so I'm going to put my 4 here, and now I'm going to write my multiple. 4 times 4 is 16. So that gives me 0. and I'm left with adding up my two partial quotients. So a part of it was 70, a part of it was 4, and that gives me 74. All right, next one, round the number to the nearest, and then you follow directions of which one it rounded to. So looking at this same number right here, 4,607 and 46 hundredths, I round to the nearest tenth. So my tenths place is here. So I look here at the ones place, and that's a 6. So because that's a 6, I round that 4 up, and it becomes a 5. Everything behind that line turns to 0. So that 6 becomes a 0, and the rest of my number in front stays the same. Same thing for this whole number. It says round to the nearest whole. So my first whole number is in the units place, right there. It's right in front of the decimal. It's that first number in front of the decimal. So now I'm going to circle the 7, and I did that backwards. I was supposed to underline the 7 and circle the 4. So let's look at the 4. Does 4 tell me that my 7 stays the same, or that I rounded up? It tells me that my 7 stays the same because it's 4 or less. So then that number now is 4,607, and everything behind that number turns to 0. So now I have 2 zeros behind my decimal, behind my units place. Round this number to the nearest 10. Well, where's my tens place? It's right here. Here's my tens place. I'm going to look at the 7. This number is 5 or more, so I add 1 to the tens place. So that's 4,610, and everything from that 7 back turns to 0. So that's why I have that 0 here in the ones place or units place, and the 2 zeros in my decimal. Okay, round to the nearest hundredth. So I'm looking at a 6 here in my hundredths place. Circle this 0. That's a 0. Anything between 0 and 4, my number stays the same. So now it's just 4,600. And again, I'll look at the number next to the place that I'm rounding. This is thousand, so I look in the hundreds. It's a 6. So 6 tells me to add 1. That becomes 5,000. I don't think you can see my decimal very good. Shh. Okay. Number 3. It says solve using order of operations. Now, I know that some of you may think that, I'll get to it. Let's just go ahead and start solving. So the first thing I do is I have 88 minus 9 times the product, not the product, the sum of 4 and 6 plus 17. Okay, so now the first thing that I need to do is, according to GEMDAS, I look for groupings. Do I have any groupings? Yes, I do. I have a 4 and a 2 in a set of parentheses. So now that I've solved that, I have 6. But Ms. Guilford, why did you leave that set of parentheses there? Well, there is no operation sign between this 9 and this set of parentheses here. So this tells me that once I solve this set of parentheses is going to act like a multiplication sign. So if I ever have a number, and here's an example, let's say I had 8 and 4 next to each other, okay? So this is just an example, guys, okay? I'm gonna write EX for example. This is an example. If I have 8 next to a 4, what this really means is 8 times 4. And that's another way to write times, a little dot in between, or 8 times 4, that way, okay? All of these things mean multiply, and that's the same thing that this means once this set of groupings is solved. Now, is this a grouping now that it's in parentheses? No, it is not. It is no longer grouping. It is now multiplication, okay? Now, why do I write my multiplication on the same line? Because multiplication and division are the exact same. These are equal. I solved them in order from left to right. Addition and subtraction is also equal. I solve it in order from left to right. Okay, so now let's look. So now I rewrote my expression, and I'm left with multiplication here inside of my grouping. I cannot leave my grouping until my entire grouping is solved and I no longer have brackets, parentheses, or braces. So now I'm going to do what's next. If I have 88 minus 9 times 6, then my multiplying comes first. So I'm going to multiply 9 times 6. 9 times 6 is 54. I rewrite, and yes, I included my braces because I did not finish my grouping first. So now I'm going to go back and go ahead and finish my grouping. I don't have any more multiplication. I don't have any division. Do I have adding or subtracting? Yes. I'm going to subtract 88 minus 54. That gives me 34. Now I rewrite without my set of my grouping set because I don't need it anymore. I solved everything in my grouping. So I bring down plus 17 and that equals 51. I know it took me a long time to explain that, guys. I hope you stayed with me with it because I really wanted you to understand that if we see a number next to parentheses, it means to multiply, whether this is a sum, a difference, a quotient, or a product, whatever is inside of here, you have to multiply it with this number that's next to it. Okay, so let's look at number 4. Number 4 says order from greatest to least, and I think I put mine in backwards, so I'm going to fix it now. I have 378. I have 37 and 38 hundredths. Now, how did I do that so quickly? I stacked each one and I checked their value, okay? And I started from my largest place value and worked my way back, okay? I never start from this way over. I always start from my largest place over to the back. So I always start from left to right when I'm checking greatest to least. Okay, so my next number is 33 and 78 hundredths. And then my next one is 33 and 38 hundredths. All right, compare using greater than, less than, or equal to. 23 and 3/10 is what to 72 and 30 hundredths. Well, let's look. Remember I start here. So my 7 and my 7 are the same. My 2 and my 2 are the same. This is actually 70 and 70, 2 and 2. And now my 3/10 is the same as this 3/10, but I annexed a 0 here. Can I annex a 0 here without changing the value? Yes, I could. So because I can do that without changing the value, then these two numbers are equal to each other. Okay, looking at the next one, let's check from left to right. My 5 in the ones and 5 in the ones is the same. 0 in the tenths, I have a 0 in this tenths. I have a 1 in the hundredths place and a 0 in the hundredths place here. So this makes this number greater because 1 is greater than 0 in that place. So 510 thousandths is greater than 5 and 1 thousandth. Okay. Week 3, day 4. Using the numbers from Wednesday, order the numbers from greatest to least, which we did up here, greatest to least, and then find the total of the 4 values. So they want you to add up each one of these. Now, the first thing that I have to do when I'm setting these up is I line up every single decimal place. I line it up exactly where it was to keep it in its proper place value. Then I annex 2 zeros here just to match the place values. It does not change how much this number is worth, so it does not change the value. Once I add that up, I got 482 and 54 hundredths. Okay, next one. Brenda says the answer is equal to 92. Rochelle disagrees. She thinks the answer is 32. Who is correct? So let's rewrite. That's 20 plus 3 times 5 minus 1. Okay? So the first thing I do, according to order of operations, is I solve my groupings. My first grouping is 5 minus 1. Once I solve that, I rewrite my entire expression. 20 plus 3 times 4. So what's the next thing I do? According to order of operations, which I wrote up here, multiplication and division come before adding and subtracting. So now I'm going to multiply. 3 times 4 is 12. Now I rewrite, bringing that 20 down again. So now I have 20 plus 12. 20 plus 12 is 32, so that would make Rochelle correct. Okay? This one is a little bit tricky. A store sells number 2 pencils for 15 cents each. The pencils cost the store 8 cents each. If 27 pencils were sold on Monday, what was the profit made from the store? Well, if they cost the store 8 cents to be able to buy, they have to buy this, and they sell them for 15 cents, I have to find the difference between the two to see how much profit they can make on a number 2 pencil. So the first thing I'm going to do is I'm going to get rid of that whole number 2 pencil thing. because that extra number just kind of can throw you off and you don't need it. So I'm getting rid of that extra information because sometimes they throw us a couple of extra numbers in a problem that we don't need. Then there's a clue down here and it says, what is a profit? It's money earned after all expenses are paid. So the expense the store pays for each pencil is 8 cents. Well, there's a couple ways I could do that. I could find out 8 cents times 27 to see how much that costs the store, and then multiply 27 times 15 cents to see how much the store made and subtract it. Or I could multiply or I could subtract to find how much each pencil makes the store. So what I did was I took 15 cents, which is the cost, which is how much the pencils are sold for, and I took 8 cents, which was the cost of the store, and I subtracted to find how much profit the store makes off one pencil. So each pencil the store makes 7 cents. So now that I know that each pencil is worth 7 cents of profit, now I can multiply it times how many they sold. Well, they sold 27. So I have 27 times 7 cents. So all I did was set it up like the algorithm, and I started to multiply. 7 times 7 is 49. 7 times 2 is 14, plus 4 more is 18. So that gave me 189. And then I multiplied my zeros. I have a 0 for a placeholder. And I have 0 times 7 is 0, and then 0 times 2 is 0. Now I add this all up, and that still gives me 189. Well, what happened to that decimal up here? I have a decimal here. I don't have one here because this is my total number of pencils, and it's a whole number. But I do have one here. So I look to see how many decimal places this is. This is 1, 2 decimal places. So I always start at the back, and I count how many decimal places. I had 2 decimal places here total. So now I'm going to start at the back, and I'm going to do 1, 2. So that's where my decimal needs to go. So now I'm rewriting the number, and I'm going to have $1.89 profit for those pencils. Number 4, Alex can evenly sort all of his trading cards into groups of 4. Circle the answer choices below that could represent the number of cards Alex owns. How does knowing the divisibility rule help you find the correct answer using mental math? Well, let's talk. We should have learned a little bit about divisibility rules towards the end of 4th grade. If not, it's not a big deal. We're going to be learning them this year through our homework. My suggestion is always to go maybe online with a parent and find the divisibility rules. Khan Academy does a great job explaining divisibility rules. Okay, so how do I know something's divisible by 4? If the last 2 digits are multiples of 4. So what are multiples of 4? A number that ends in 4, a number that ends in 12 or 8 or 16 or 32, 20, 24. Those would all be multiples of 4. So I'm looking at 316, and I underline the last 2 digits in each number, okay? So now looking at 316, my last 2 digits are 16, and I know that 4 times 4 is 16, so yes, it's divisible. 612 has a 12 in it. Yes, it's divisible by 4. 34, no. It would have to be like 332 for it to be divisible by 4. So that number is not divisible by 4. 626, no, that can't work. 624 could work, but not 626. 342, nope, that won't work either. Maybe 344 could have worked, but not 342. 620, yes, that number can work because 20 is there, and 4 times 5 is 20. I hope the homework helps. This walkthrough helps. Please make sure that your homework is complete and turned in tomorrow. Thank you.